Okay, so let's have another topic here. So in the previous slides, we have had an example of solving recurrence relations. So going back, what are the steps? So first, finding the degree, and second, it is finding the characteristic equation, and third, finding the roots of those characteristic of that characteristic equation, and four, finding the constant na coefficients, and lastly, to write the closed form expressions. So in the previous example, we've had this characteristic equation r squared minus r minus 6 equals 0. So if we factor it out, its roots are r1, r sub 1 equals 3, and r sub 2 equals negative 2. So they have two distinct roots. So what if we have this characteristic equation instead? So r squared is equal to r squared minus 6r plus 9 equals 0. So if we factor it out, it gives us the same value, the same roots for r1 and r2. So basically, we only have one root here. Okay? So with actually the closed form expression will vary since we have the same roots or the same roots are sub 0. Okay, so let's see sub 1 and c sub 2 be real numbers, wherein c sub 2 is not equal to 0. So suppose that we have this recurrence relation a sub n equals c sub 1 times a sub n minus 1 plus c sub 2 times a sub n minus 2. Okay, so if we have its characteristic na equation, then it's just of the form a sub n equals r raised to n. So we simply substitute r sub n to every a. So we have r sub n equals c sub 1 times r raised to n minus 1 plus c sub 2 times r raised to n minus 2. So if you want to understand this more, so we have discussed this in depth in the other video. Okay, so with this, assuming that we have this characteristic equation and it has only one root, let's say r sub 0, only one root, one root r sub 0. Just verifying if I'm still recording. Okay, so we then have this closed form solution, a sub n, a sub n equals alpha 1 r sub 0 or r naught raised to n plus c sub 2 times n times r sub 0 raised to n. So notice here the r sub 0 in the two terms. Okay, so since we only have one root. So we are going, if you have different na roots, then yung gagamitin natin na closed form solution ay ito. So a sub n equals alpha 1 r1 raised to n plus alpha 2 times r2 raised to n. But if the same yung roots niya, then yung gagamitin natin na closed form solution ay a sub n equals alpha 1 times r sub 0 raised to n plus c sub 2 times n times r sub 0 raised to n. Okay, so let's have an example. So assuming that we have this recurrence relation. Let me change the color.